Hello everyone, thanks for joining. I'm Kishore Chavakula, Technology Evangelist at Delboni. I'm here today with Parthik Singla, a dear colleague of mine, another Technology Evangelist at Delboni. We both are here to illustrate the advantages of event-driven microservices architecture for traditionally followed microservices architecture. In this session, we would like to cover the adoption of microservices, challenges associated with the microservices approach, and an event-driven microservices solution to address those challenges. Also, we would also like to demonstrate the benefits of EDA by going through a lead to cache use case. With that agenda being said, let's begin the session. Next slide, please. Transformation is everywhere. We all have seen transformation across the businesses and business lines. Technology is also changing rapidly to adapt to the business needs. For the last few years, organizations have been striving for continuous business transformation and have moved from traditionally implemented monolithic applications to S4A. To drive the speed and to meet the continuously growing business demands, IT often requires to redesign the applications to domain-driven microservices models for better scalability and agility. There has been a shift from monolithic to S4A to microservices. If you observe, the way we used to expose services, the way we used to handle the service registry in S4A architecture is completely changed within the microservices architecture. Services has become more tiny and autonomous unit of work with its own life cycle. This will surely drive agility and scalability. But remember, these are microservices which communicate between each other. The communication between microservices is point to point and synchronous in nature. Well, is that a problem? May or may not be. But definitely there are some challenges associated with this approach. Let's take a look at the challenges associated in this microservices approach. The limitation with microservices synchronous request response pattern is that the client dictates which service will process the request. On the other hand, the calling service thread is blocked until it receives the response. It's a challenge for thread management. Synchronous architecture with point-to-point integration of microservices cannot handle the performance at a scale, especially when multiple services invoked in parallel. Hence, application faces challenges with communication latency in distributed environments. One more challenge is API URL. Clients must know details of the API and the location. Also, the services must be available at the time of the request is being made, meaning it's not loosely coupled. Another challenge is microservices architecture is prone to recursive breakdown. A single service failure in the system may overload the system and prone to recursive breakdown. When a service calls another service and this service does not respond in time, the calling service will also fail because it was expecting a response. This can cause a waterfall of failing calls leading to a breakdown. Of course, one can implement a circuit breaker pattern to a certain degree of satisfaction. Microservices are stateless and independent. Traditional logging is ineffective, meaning limited visibility across end-to-end transaction. The logging must be able to correlate events across several platforms. In microservices approach, services are independent, but still there is a need for orchestration of services, and that is bringing the complexity and challenges to the microservices architecture. Let's see whether event-driven microservices architecture can address those challenges. Next slide, please. Event-driven architecture establishes a synchronous integration between microservices. In EDA, we deal with events, not with messages. Event publishers won't wait for event processes. EDA is not point-to-point. An important point when building microservices-based application is the way you integrate your microservices. Ideally, we should try to minimize the communication between the internal microservices. The goal of each microservice is to be autonomous and have to be available to the consumer, even if the other services that are part of the end-to-end application are down. The fewer dependencies between microservices is better. Communication can be decoupled using the event-driven architecture. Each service is highly independent and will react on events. EDA allows multiple applications to communicate simultaneously and rapidly. In real time, EDA is considered the best way to enable a synchronous event-driven application interaction. EDA is well suited for developing data integration applications which are responsible for capturing, aggregating, and processing data from multiple diverse sources. With that context being said, I will hand over to Pratik for a lead to cache demo. Pratik, over to you.
Thanks, Kishore. Hello, everyone. Now, with a brief background of the microservices and the event-driven approach, let's have a quick look how we can redesign a common use case that's lead to cache using the event-driven microservices architecture. Lead to cash is a quite common use case present across many organizations. It basically starts from the lead generation and ends till the revenue management. In between, there might be multiple phases like sales order management, configure price code, customer service, revenue management. For this particular scenario, we are considering sales management and the order management and trying to modernize this particular use case using an event-driven microservices architecture. Let's have a look. Assume that we are having a CRM application where we are managing the customers and the related opportunity record. And whenever there is a change in the opportunity state, we are capturing that as an event and logging or publishing that event to an event streaming platform. So event can be considered as any significant change in an application or any action. Unlike messages, event is something which a business user can correlate to. In this particular scenario, as we are moving opportunity among different stages, like from qualification to prospecting to closed and won, we can capture these changes as an event and publish these changes to event management platform. In this particular scenario, I am sending the events to the event management platform from CRM using HTTP protocol and logging into a particular topic. So here we might be having two microservices. In this case, we are having order creation and the customer creation as two microservices which are hosted onto iPaaS platform. iPaaS platform is responsible to manage the subscription with the event management platform and process the event messages and establishing the integration with the ERP application. So right now, these two particular microservices are interested in consuming the event messages whenever the opportunity state is changed to closed and won. So these two microservices can consume the event messages parallelly and filter the events based upon the opportunity state that is closed and won. Additionally, there might be additional services which are hosted outside of your core network. So usually there is a communication challenge and there are security restrictions to integrate the applications which are hosted outside of your core network. So in this scenario, if we are having external service, that's a credit check service, which is hosted outside of your network. So we can solve those challenges, communication challenges, overcome those using an event distribution message framework. What we can do is we can host an additional message broker onto our event management platform and synchronize the events between these two message brokers using an event distribution mesh. Event distribution mesh can be responsible for synchronizing the messages between multiple brokers which are interconnected using the event distribution mesh. So whatever event is published onto the first message broker will be automatically synchronized with the second message broker using the event distribution mesh. And likewise, any services which are hosted outside of your core network can get connected by hosting a local message broker and adding that message broker to the event distribution mesh. So in this case, we can have three parallel subscriptions to the events when an opportunity state is changed to closed and won. And these three services can get invoked parallelly. Moving on, once the customer creation services is done processing the event, it can publish the changes or the update to another topic, which is customer status. And once it's published, that particular event can be further consumed by the order creation service. And similarly, once the order creation service is done consuming and processing the event, it can publish the updates to another topic, which is order status change. And then there might be additional subscribers to this particular topic. In this scenario, we are having an event notification event, which is sending out an email notification to the customer. And then there is another subscription for the CRM update service, which is updating the status into the CRM application. Now, going back previously, when we talked about the events which are published from the CRM, we were capturing all the status changes as an event and publishing it to a topic. And in this particular scenario, we have consumed only the event where the state is changed to closed and won, but we can capture all the other events which were sent over to the event management platform and store it into a persistent event store for doing a reporting or analytics. So in this particular scenarios, we can also use that event store to recover from failure in case of any application failure at certain point in time, right, by rebuilding the application state from some reference point back in time and by replaying the events from that particular point in time. So this particular architecture provides us a lot of flexibility and agility. In this scenario, in case you have to replace any of these microservices with another service, you can easily plug and play and replace that service with another service For example, tomorrow, in case we are onboarding a new CRM application, suppose a separate business group or a different line of business has onboarded a new CRM application, so they can just event enable that particular CRM application and start publishing the event messages onto the event streaming platform, and the whole framework will work without any core modification to this particular solution. Let's see some of the solution highlights, what all benefits this particular solution provides. First of all, it provides us a purely decoupled publisher and subscribers. So publisher need not to know where the subscriber is or where the event handler is. Publisher can just send the events to the event streaming platform, and all the subscriptions between the event handler will be managed by the event management platform and will be managed by the event handler. Publisher need not to worry about the state of the event handler while it's sending the message to the event streaming platform. And event handlers can consume the messages based upon their interest. So they can filter out the events based upon their interest. In this previous scenario, the event handlers were filtering out the messages based upon the opportunity state, that is closed and won, based upon the topic string. And this particular framework also allows the asynchronous processing of the events. The event producer can just publish the message onto the event streaming platform without waiting for the event handler to process the message and return the response. So it can release the communication thread as soon as it has published the message to the event streaming platform. And this provides us a great scalability, and it provides us a optimization in terms of the resource utilization as well. And this particular framework is also capable of handling a sudden spike in the event messages. For certain scenarios, if there is a sudden increase in the workload, the event streaming platform can absorb that workload, and the event handler can process the events based upon their capacity, and we can further scale the event handlers independently based upon the workload. Additionally, we can also interact with the event management platform using multiple protocols. In the previous scenario, the CRM application was sending the events to the event management platform using HTTP protocol, and the order creation and the customer creation microservices were consuming the events based on the JMS protocol. Likewise, different event producers and event consumers can leverage different protocols and connect to the event management platform depending on the protocol of their own choice. So these whatever protocols we have mentioned over here are usually supported by different event management platforms. And this also provides us a flexibility to work with the applications which are distributed across different networks. So Event Mesh allows to synchronize the events across different brokers, and brokers can be distributed across different networks. It could be depending upon where your applications are residing. So you can have brokers residing in different networks, and you can create a connectivity between those brokers using an event distribution mesh. So this facilitates to integrate the applications which are present on a distributed infrastructure. It could be a multi-cloud infrastructure, or it could be infrastructure with your partner, and it could be a scenario in case of different lines of business. And this particular framework also allows you to persist the events as a persistent data store, which can be leveraged further for reporting, analytics, or to recover from the failure and rebuild the application state. Talking about the high-level business benefits, this particular framework provides us extensive scalability in terms of enabling onboarding of different event producers and consumers, which can be distributed across different networks. And the loosely coupled architecture provides us a flexibility in terms of onboarding different applications, and we can change the subscriptions to those applications. We can even upgrade the application. So for example, in case today you are using a particular ERP application, which is a legacy ERP, and tomorrow you need to upgrade that to a cloud application. So you can simply migrate your ERP from on-prem to cloud, and you can just plug and play a different event handler to process the event message without changing the core architecture. The event producer need not to wait for the event handlers to process the message. They just release the communication thread as soon as the message is published onto the event management platform. So that provides more flexibility, and the system tends to be more performant. Since every change or every activity is logged as an event, we can use that event logs to recover from application failure by replaying the events from a certain point in time and reestablish the application conditions. So this provides us more resilient and fault tolerant architecture. The any errors can also be logged as an event, and we can use those events to reinitiate the application transaction to recover from failure. So these are the high level benefits what we get as part of this event driven microservices architecture. That's it we have. Next up is the demo. All right, let's see the things in action with this demo. Assume that this is our CRM application where the sales rep will work on the accounts and the related opportunity records. Let's create a new account record for demo purpose. We'll enter all the required information. So we are creating a new account record into the CRM application. And the next sales rep will create a new opportunity record for the same account. Let's mark all the required information, close date as something in future, and the initial opportunity stage as prospecting. We'll add a couple of products to this, these two, and mention the quantity as say 1 and quantity as 4. So this is our new opportunity record in the CRM application. As the sales rep will keep working with the customer on this opportunity, he will be updating the opportunity stages into the CRM application. And we have event enabled the CRM application to capture all the changes to the opportunity stages and capture this and publish it as an event onto the event management platform. We are using Solace as our event management platform for this particular demo. Whatever changes we are doing to the opportunity stages are getting logged into the Solace, and there will be different services or the different event handlers which will be consuming those events based upon their interest. So we are having the customer creation and the order creation services which will consume the event when the opportunity stage is changed to closed and won. They will be filtering out the event based on the opportunity stage. And then we will be having additional services which are logging data to the event store. So those event handlers will be consuming the events, all the events for all the opportunity stage changes and logging the data to the event store. So we are using Kafka as our event store, and we can see here, once we have changed the opportunity stage to qualification, that has been logged onto the Kafka console, and we will be using this information for feeding the data to data lake or reporting application, or we could even use this data which is stored into the event store to rebuild the application state in case of any failure. So let's change the opportunity stage to another stage as well to verify this. As soon as we are changing it to the another stage, that change is also getting logged here onto the event store. So this is our new opportunity stage that is getting logged, and this is our previous opportunity stage. Now let's change the opportunity stage to closed and won. That's where our other event handlers, which were processing the data through the ERP application, were getting invoked. So let's change this to closed and won. Before doing that, let's quickly verify whether those services were invoked when we change the opportunity stage to previous stages as negotiation review and all. So this is our Boomi as iPaaS application where we are hosting the services like order creation and the customer creation and the credit check service as a microservices, all independent of each other using the event-driven architecture. Now, if we refresh, we don't see any execution of those services because the opportunity stage has not moved to closed and won. Let's change the opportunity stage to closed and won and see what happens. Now, if we go to our iPaaS application, which is consuming those events, we can see that two services are getting invoked, one for creation of customer and another for creation of order, right? So the flow will continue. It will fulfill the order into the ERP application, create a new order and update the status into the CRM application. So let's just refresh the screen. Into the CRM, we can see a new SAP order has been created. So this is our SAP sales order number. And similarly, if we go to the account record in the CRM, we can try to verify if a new customer has also been created. So this is the new customer number which got created into the SAP system using the event-driven architecture. So new customer has been created and a new order has been created. Let's try to verify this into the ERP application. Let's log into the ERP application. Here, we'll first try to verify the customer. We'll enter the customer number over here. The data is not copied yet. So here we can see whatever name we have given in the CRM, the same customer with the same name is getting created into the ERP system. And we are using our iPaaS platform to establish the connectivity between multiple applications to process the event messages, which has been published onto the event management platform, consume those events and process those events, transform those events and establish the connectivity and create the data into multiple applications. So ERP, the SAP application is one of those applications. Similarly, we can try to verify the orders as well. Let's go to the opportunity screen and take the order number. This was our order. We can see here this order, there is a sold to party, shipped to party with the customer and the billing address. Right. And these were the other order details. Sorry, let's close this. So here we can also verify the products which we have added with the respective quantities. The order has been successfully created in the ERP application. Let's see how the things have happened. We have already seen a new event has been triggered. The event is logged to the event store. We have all the changes to the opportunity stage logged into the event store. And once the opportunity stage is changed to closed and won, we were having these two services getting invoked, the customer creation and the order creation services, which is processing the event and creating order into ERP application. And once the order is created, those changes are again published onto a separate topic onto the event management platform, where there were two additional services, one for sending out the notification to the customer, which we can check here onto our email box. So this is a new email notification which has been published to the customer mentioning his order number and the customer number, which got created in the ERP application. And similarly, there was an additional service to update the status into the CRM application. So whatever status change we have seen in the chatter here into the CRM application is done by the service which got invoked in parallel to the notification service. And again, we were having additional service to do the credit check. This is the service which got invoked. So this we are hosting onto another account. Reason being, this is an additional service which is hosted outside of the core network onto a distributed network onto a separate WAN. So ideally, it's not possible to publish the event directly from the CRM application onto this service because it's hosted outside of your core WAN, and there will be security and communication challenges to reach out to these particular machines. So we have overcome those challenges using the event mesh framework. So within Solace, we were having multiple brokers, one onto the North America data center, another onto the Singapore data center. Our initial events are getting published. All the opportunity state changes are getting published onto a Singapore hosted message broker, and our credit check service is hosted onto a North America data center. And we have established the connectivity using the event mesh framework. So we have connected these two message brokers using the event mesh framework. And whenever we are publishing the events onto any of these message broker, that automatically gets synchronized to the another broker as well. So whatever events we have published onto the Singapore data center are getting synchronized onto the North America data center, where our credit check service is getting hosted and listening to the events. And after processing those events, it can again publish the events response onto the same message broker. And those event response will also get synchronized to the Singapore data center so that we can proceed further with our use case flow. Within Boomi, we are having these particular services. So Boomi as iPaaS platform is allowing customer to establish the end mile connectivity. So let's have a look at some of these processes. So within these processes, we are actually establishing the connectivity to we are doing the business logic, all the data transformation, and then we are also establishing the connectivity to the SAP systems using the connectors what iPaaS platform provides. And similarly for the CRM application, we are establishing the connectivity to the CRM application using the connectors. So here in this scenario, we have achieved out the end-to-end use case for sales order management and sales order and the order management using the event-driven microservices architecture. These three microservices, the customer check service, the order creation, and the customer creation services were hosted onto the iPaaS platform. And we have communicated between these services using the event-driven approach. So this makes this whole framework quite agile and flexible. We can onboard additional services in future. We can subscribe to the events in parallel, and we can also onboard new application. Assume that today a particular business unit is using Salesforce's application. In future, they switch to a different CRM application, or a separate unit is using additional application. So they can just event enable that particular CRM application and start publishing that event onto the same architecture or to the same framework without having much changes, and they are good to go. So this provides us quite good amount of flexibility and agility, and we can scale these services, whatever services we have individually based on the workload. So the events will be first consumed by the event management platform. So if there is sudden influx of data, sudden increase in the load, that can be consumed by the event management platform, and these services can consume those events based upon their availability. We can persist the events onto the event management platform and consume it in aggregation mode or in a real-time mode. And all these services need not to wait for one another. It can just release the threads as soon as it's finished and publish the changes as events again to the event management platform, so that another service can consume those events and process that event further. So this is what we have as part of this. Thanks again for joining in. Hope you have some good takeaway from this session. Feel free to post your queries and questions onto the Q&A session. Thanks for your time again. Have a good day.